Hello, in this video we're going to start looking at how to add some very basic MMO style monster AI in Unreal Engine. And basically we're going to be creating some simple behavior trees for our monsters in Unreal Engine such that they're able to have some combat with our player. So do bear in mind this is the initial introduction to AI, so it will be implementing some pretty trivial logic, but it's something that we're going to be incrementing upon in later episodes, right? So we're going to be expanding the use cases, we're going to be expanding the behavior trees and making some more complex behaviors implemented. So as usual, all the steps to replicate this are available on this blog post, so check that out if you'd like to reproduce it. In this video we're going to be going through the high level, so we're going to be getting introduced to all of the features and functionality, but all of the steps should be available in this post, so do check that out. As usual, this is the link to the Micronaut backend server that I'm using while I'm basically experimenting with this. So I'll add both these links in the description. So let's get started with a demo. Okay, so let's begin with a quick demo. So what I'll do is I'll log into one of these characters. You can see the Unreal Engine server is spinning up. So this is the one that will spawn and control the monsters. And they're being synchronized via the Micronaut server, which is just running over here. And what will happen is as soon as this monster sees my character, he'll just start running to attack me. So from the previous episodes, you've seen that I was able to start attacking the monsters back, so that's still working. I had to do some refactoring on the back end to support the monster attacks, but now you can see this guy will chase me and trying to kill me. I haven't implemented the death yet. So when the monster takes me down to 0 HP, I actually just get 300 extra health, so I haven't implemented the respawn system or anything like that. So when I kill the monster, it goes ahead and respawns it, so I have a respawn point. And again, if the mob sees me, he'll just run and start attacking me. So that's kind of what we have right now. So you can see this is some pretty basic implementation. There's obviously some bugs. So for example, if I go out of sight for this guy, he'll start roaming again, right? So if I just go like this, he does some funny stuff like starts to roaming around. And this is mainly because I've gone out of sight for that monster. So this is some trivial fixes that we'll implement in the future episodes. For now, I think this is enough for the scope of one post, so that's why I've sort of drew the line here for now. So let's go over how to build what I've got so far. Before I go too deep into the implementation on my side, I wanted to quickly again share this link. This is a part of the blog post as well, but I also used this specific video to brush up on my knowledge with behavior trees. So this one specifically goes over the AI detection and chasing, which is primarily what we're doing in this episode. So I want to make sure to give this video some credit. So do check it out if you're basically getting stuck on any points, as it will also cover some material in maybe slightly different ways. So will be worth having a look at that. But let's basically get into what we have and go from there. Okay, so perhaps we'll get started by giving some perception AI to our mobs, and the way to do that is to create an AI controller and create some components to handle that here. So these AI controllers will assign to our monsters, so any components that this AI controller has will essentially be inherited by the monsters as well, right? So in order to add this AI perception on the components, just search AI and you'll be able to find this AI perception component. So you'll also want to configure it a little bit perhaps. So what you'll want to do is add this site config for the perception, and you might want to leave things like the site radius, etc. as default. I've actually increased mine just to make things a little bit more tricky for the player. But feel free to experiment with them as you like, and this is essentially the place where you'll do those little configurations. So once you've configured this in place, what we'll need to do is also add a AI perception stimuli source to the player. So you'll want to basically have the eyes on the monster and also some stimuli source on the player, which will essentially trigger this perception, right? So let's have a look at that next. So my players will actually be represented as player proxies in the game. So we're not actually spawning the player class, but rather these player proxies. So I essentially needed this AI perception stimuli source to exist on the player proxy. However, I've actually added this perception stimuli to my base class. So basically, the parent class of this is player character base, and above that is this actor base blueprint. So this one is basically shared amongst all of my character and monster blueprints, and this is mainly because I wanted my monsters to detect everything, right? So I wanted them to detect players, I wanted them to detect other monsters, and this is to really just add some additional features in the future so that maybe monsters will attack other monsters and things like that as well. So this is what you might need to do. It depends on whether you want to create a common base class and add it there, or perhaps you just want monsters to detect the player, so perhaps you'll just add it there instead. So again, you just want to add this component AI perception, and it will be the stimuli source. And once you've added it, you just want to add this AI sense site, and you'll need to also auto register it. So those are the key things you'll need to do here. And one less obvious thing that you might need to do is also inside your game project, you're going to have this default game configuration file. And if you edit this, you'll also need to do this auto register all pawns as sources equal false. So this is also documented in the blog post, so check that out. This will be required to avoid some bugs essentially in the game. So let's have a look at what we need to do next. Okay, so let's go back to the Mob AI controller where we've added our AI perception. And so now we have our monsters configured with this site, and our actors, including our players, have the stimuli source for this perception as well. So let's implement what happens when the perception is updated. So this is essentially triggered when there's an actor with a stimuli that gets in the view of this monster essentially, right? So this will automatically get triggered. We're going to check the sense class for the stimulus. So we've only configured the site in this case. So we just double check that to make sure it's true. And then I'm going to take my actor and cast it to the actor base blueprint. So this is the one where we've added the perception stimuli source. And the reason I do that is so that I can determine whether this actor is a player or another monster, right? So this is a common class for me, so I just want to make that distinction. You might not need to do that in your case, but again, I'm just highlighting some of the options that are available. The next thing I do is just check against this successfully sensed boolean, which represents whether the monster has come into the site or out of sight, right? Because remember, this is a delta, this is an updated rather than a state. So it just tells me whether this actor it has now come into the view, in which case it will be true. And I just check whether my actor is a proxy. If it's a proxy, it just means that it's a character, so it's a player. So I only implement my logic for when it is a proxy. In the near future, I might want to make combat happen between different mobs, in which case I'll also be leveraging things like tags. So we'll basically cover some of that stuff later. But at the moment, the key things are, did the player come into the view or out of view, which is determined by this successfully sensed. And I just make sure that I process it only if it's a player, which it means is proxy is true. So that's what we have here. So let's check those out. So perhaps before I go inside of these functions, which will essentially rely on things like Blackboard, I'll want to just introduce the behavior trees and the Blackboards first. So we'll loop back to this shortly. And before I do those, I want to also make sure that I've introduced how to actually configure your AI controller to your monster classes, right? So remember, we have our monster blueprint, and this one is has the mob base actor as the parent class. So what I want to do is inside the mob base blueprint, I want to click on the class defaults, and I want to find the AI controller here, and I want to update the AI controller class to the mob AI controller that we've just created, right? As well as this, I want to make sure that auto possesses AI is set to placed in world or spawned. So this will make sure that that controller is always in control essentially, and this will only get impacted on the server. So if you're playing on the client, you don't need to worry about it, because this only takes effect on the server. And now if I go back to my mob class, you'll be able to see that it just simply inherits these values. So that's kind of the benefits of having these parent classes, so that you don't have to repeat this logic, so you're not really going to forget making these updates. And it's the same thing on the possess, right? So with these settings in place, you'll know that now your controller is in action, and now this monster will have this AI perception. So it's not going to be on these components, but it is inherited via the mob AI controller. So with that done, let's have a quick introduction into the behavior trees, and then we'll go back into the processing. Okay, so let's start with behavior trees. So we'll only really look at two specific behavior trees, which is roaming around and this combat decision, which is really just chasing down our target. So I've basically added both of them inside the basic mob AI, which will be essentially the entry point for our behavior of the monsters. So from the AI controller, we'll basically say execute this behavior tree, and it will just keep running this, right? So let's have a look at what happens here. So the first thing that it will try and do is this combat decision, which is really chasing down the target if one is available, and if not, we're just simply going to roam around. So this is the key distinction between a selector and a sequence. Selector just means that we'll execute only one branch successfully, and we'll prioritize from the left. So we'll try and execute this. If this fails, we'll try and execute that. If this fails, it'll go on to the next one, right? Whereas a sequence, so you'll be able to see here, a selector and a sequence, it will execute everything from left to right. Okay, so that's the key distinction between selector and sequence. And it also means that, to be honest, this one should never really get executed, but it's just there in case, you know, we need to debug something. If something dodgy is going on, we'll be able to see that it's falling into here. So the two key behaviors are actually this one, so combat decision and the BT roam. So before I go into the blackboard, I'll actually look into the tasks and the actual functionality, and then we'll look into this blackboard conditions as well. So let's have a look at what happens inside the combat decisions. So here, this is super simple for now. This is mainly because all I'm doing is chasing down the target, and I don't need anything else at this point in time. But later on, I might try and potentially I'll even change this to a selector. So maybe I'll choose, do I do a special attack? Maybe I'll do a skill to attack or to heal, or maybe I'll chase them down and just do normal melee or a ranged attack. So this will get a bit more complex later on. But for now, you know, it's just some pure simple chasing. So let's have a look at how we actually implement a task now, which is inside this behavior tree. Okay, so in order to create a task, what you'll have to do is right click and go blueprint, and then just simply type task here, and we're creating with a parent of BT task blueprint base. We're also able to confirm that by simply double clicking this, and you can see the parent class here, which is the BT task blueprint based as expected. So you can see one of the first things that I do is get a blackboard value. So let's basically create that blackboard first. So you can see it exists here, and to create that, right click, artificial intelligence, and blackboard. So what is a blackboard? It's basically a data store. So it's somewhere you can store these parameters for use between your behavior trees and your AI controllers and things like that, right? So basically it's a blueprint which stores your values. So the other thing you'll want to do is actually configure it inside your behavior trees. So when you have your behavior tree open with nothing selected, you'll have this option to set the Blackboard asset. So this is where you'll want to configure the Blackboard to be used by your behavior tree. So it's the same thing here as well. If I unselect that task, you'll be able to see the Blackboard asset pop up, and I'm able to select it. Okay, so once you've created the Blackboard, inside it, we'll want to create just two parameters for now. The first one is the move target location. So this is going to be a vector class, which is representing the point in space we're going to move to when we're random roaming. And then the second one is the combat target. So this is essentially the player that we'll be chasing, and this will be an object class, right? So this will be the object or an actor that will be essentially chasing. So once you've got those configured, we'll be able to go ahead and implement this chase target task, right? So let's have a look at what we have here. Okay, so let's start looking inside this task to chase the target. So what we first do is grab our combat target from the Blackboard value as an object. So in order to do that, we've created a variable for the combat target. It's a Blackboard key selector type, and here I also made it instance editable and expose on spawn. So I've done the same for the acceptable radius, and this is so that we're able to actually control them from our behavior tree. So inside here you can see that once I've selected this task, I have these default value options available. So the combat target, I'm able to select that, and from the controlled Blackboard values, I'm able to then select my combat target, right? And then for the acceptable radius, this is just another hard-coded parameter for now, and I basically say, you know, this is the acceptable radius to reach when I'm chasing this target. So let's have a look at how that's used. So the controlled pawn is the monster itself, and I basically ask the monster to move to the object which is taken from the combat target, right? So I grab my Blackboard, I take my combat target out of the Blackboard, and I basically ask my monster to chase it up to this acceptable radius. And then I just simply finish execute. So this one will actually do everything that I need in order to chase the target. So really useful to have this AI move to. You will need to bear in mind that you need to have a navigation mesh created for this to work. So if I open up my maps, so there's Tuxworth, so you'll see that I actually have a navigation mesh which wraps all of my map essentially. So this is also covered in the blog post, but basically there's a navigation mesh that just extends to outside of the map, but this will basically allow the AI move to work, because this is basically a requirement for it. So don't forget that if you don't have it, even if you execute that AI move to, the monster's not going to go anywhere, so you will need to add that. Okay, so now that we've implemented the task for chasing the target and we saw the Blackboard being created, perhaps we'll want to have a look at this decorator next. So in order to add the decorator, just right click, add decorator, and select this Blackboard over here. So there's many types of decorators available, and really they're able to sort of encapsulate logic in some more logic, I suppose, right? And there's some pretty cool features available out there. So in this particular one, I suppose it's pretty much like a fancy if statement. We're basically saying if the Blackboard key combat target is set, then you can execute this function. If it's not set, go on to do something else. We're also able to add this flow control of saying that if that value has changed, then you'll want to abort yourself as well. So this is some pretty useful functionality to have on these features. So for example, we only want to chase the target if we have a combat target to chase. So don't even bother going inside if we don't have this combat target. and it's actually the opposite for the roam. So we want to make sure that we don't roam if we don't have roam if we have a combat target, right? And again, if this has changed while you're roaming, then you want to abort yourself and go on to do something else, right? So it's the same thing for this wait statement. So you'll only wait as long as you don't have a combat target. Otherwise, you go here. So that's how we sort of complete this loop, making sure that we only execute relevant functions as and when required. So now let's have a look at how we implement this BT roam. Okay, so let's have a look at this roam functionality for our mobs then. So this behavior tree will run in a sequence, which will mean that it will just execute these three functions in order from left to right. The first thing that it'll do is find this random point, which is the task that we create. So the parent class here is the BT task blueprint base. And again, we'll have two variables here. So the first one is the move target location. So this is what we'll update inside the Blackboard value, and the radius, which is how far away do we want to roam from where we are right now. So let's have a look at how we defined it over here. So you can see with this task selected, I have these values exposed. So the move target location is just set to the move target location from our Blackboard, and then the radius I put as 1,000. So you can play around with the radius as you like, but this is just basically the radius that you'll roam around randomly in from your current location. So let's have a look at the implementation here. So we grab our controlled pawn, which is the monster, and we get a random reachable point in the radius, where the radius is the one that we've defined in the behavior tree. And then we take that random location and we set the move target location to this value, and then we simply finish execute. And by the way, if you don't finish execute here, it will hang, it will have some issues, so don't forget to click finish execute in all of your task classes. Okay, so then we simply ask the monster to move to that location. So this is a just a native class or native function that's available directly from the tree. And all you need to do is just specify the Blackboard key that you'll want to move to. So this will have to be the vector, and it will go ahead and simply move to it. And then we can use another native function for wait. So again, it's just available by typing it in, and we just say to wait 3 seconds with a random deviation of 2 seconds. So the maximum wait is 5 seconds essentially. And that's basically it. So this one will find the random point, move to it, and simply wait for a little bit of time before going back to the basic mob tree. So perhaps something that you may have noticed is that we haven't actually updated or set the combat target inside these trees, and that's because it's controlled by the mob AI controller. So I'll now go back to the functions that we saw earlier: process add actor and process remove actor. So as perhaps you guessed, this will update the combat target for the monster. Okay, so if we double click that, let's have a look at what this actually does. Okay, so the first thing that I want to do is basically keep track of the detected players, right? So I have this map of string to actor base blueprints. So I basically want to have these actors tracked locally, and this is so that in the future I'm able to start applying logic like threat levels and attack the actor with the most threat on it, right? Just as an example. So that's kind of the rationale here. And I've already filtered the actors here to be only players. So this is we've done that by basically just checking if this is a proxy. So this is something specific to my server. And I've also made sure that these are actor base blueprints. So all of my actors will also always be associated with a unique actor ID. So again, you might have something slightly different here. So feel free to implement it as you like, but the key thing that you'll need to do is basically check, does my character already have a combat target. So I get the blackboard for this mob AI controller, and then I get the value as the object. And specifically, I'm looking for the combat target. So if I don't have a combat target already, then I want to set it to the newly found actor, right? So because if I already have a target that I'm chasing and a new player comes in, I don't want to start chasing the new player. I want to continue chasing the one that I was already chasing, right? So that's why this is only done if we don't currently have a combat target in place. And what do? We simply set the combat target to the detected actor. So that's what we need to do. Something that's quite specific to my server is to send the attack request. So my Micronaut server will be doing all of the validations, like, you know, are you within distance threshold, are you facing the target, things like that. So all of that is done by my backend server. So it will simply get the actor ID and it will create a request to the backend server to try and attack it. And you can see that it's then taking the socket integration and sending that message to my server. So that's what we do when we process the add actor functionality. And then there's also one to process remove actor as well. Okay, so what do we do inside the remove actor? So we first of all want to just remove it from the map of tracked actors so that we don't get bothered by it in the future again. And then we want to check, is the combat target inside our blackboard the actor that we're essentially removing right now? Because if it is, that means we need to reset it. So that's what we're doing here. We're getting the combat target, we're just casting it to the actor-based blueprint so that we can access its actor ID, and we check, does the actor ID of our combat target equal to the one that we're removing right now? And if it is, that means we want to reset the combat target on our blackboard. So that's what we do right here. So in the near future, we're going to be applying some other logic here. So we'll actually not want to set it to null. We want to grab our detected actors and take something from the list if there's anything there. So at the moment it just simply resets it. That's mainly because I'm just experimenting with one player right now, but obviously there'll be other logic to implement here as well. And we'll also want to request our server to stop attacking that target as well. So there's a couple of things that we still need to do, but for the very basic functionality, this is sort of acceptable. I mean, certainly it's not in an MVP stage, but it is in a demoable stage. So one of the things that I'll be looking at next is also only removing the detected actor if it basically comes out of a threshold distance. So even if the monster loses sight, I'll want them to still chase it unless you've gone too far away, right? This is some changes that I'll add next, but that's basically it for this stage. So let's have a look at perhaps another demo. Okay, so I'll go ahead and click play, and again I'll just go into one of the characters. This will just spawn up. So what we'll have is the monster spawning somewhere randomly in this area. So I'm using an asset for that. It's also referenced in the blog post. As soon as I become visible to the monster, he'll start chasing and attacking me. He'll keep chasing me as long as I'm in the vision. So as long as the combat target is set in the behavior tree, he'll keep chasing me. So you'll also see that if he loses sight of me, which I'll just try and replicate shortly, he'll continue going into his random roaming mode. And this is because the combat target is not set, and then he'll start chasing me again as soon as I come in sight. So I've already shown the implementation for me basically killing the monster, and then they'll get deleted and respawned by the AI spawner system. So that will just happen as expected. The new mob spawns and starts attacking me. So I've implemented some logic that when in the server the monster kills me, I'll just get some health and he'll stop attacking me. So it basically sends a stop attack request. So this happens internally in the Java server. And soon I'll need to implement some death states for my player, so perhaps a respawn system for the player. I'll perhaps need to implement some, XP system, some level up system. I'll still refine the AI in the combat a little bit more, so that, like, for example, the monster still keeps track of the player, even if I go behind the monster, right? Like, it doesn't really make sense that they'll just go back to roaming. So a couple of improvements there, and then perhaps I'll also look at, skills, level ups, and all of that good stuff as well. So lots of things to cover. But that's it for now. Thanks, and yeah, I'll see you next time. Bye.